Hey, it's Neil from Gradesavers, and today we're doing question number 47 from section 7.2. The question reads, what is the integral from 1 to 4 of ln of root x plus 1 dx? And they would like for us to do an appropriate u substitution before we begin integration by parts. So let's begin. In order for us to do a u substitution, we need to select a u, and we will let u equal to root x plus 1. This means that dx is equal to du over the derivative of u, which in our case is 1 over 2 root x. And to simplify this, we get the 2 root x in the numerator times du. Now, because this is a bounded integral or a definite integral, we need to convert our bounds. Right now, the 1 and 4 are in terms of x. We should convert them so that they are in terms of u using this relationship right here. So when x is equal to 1, u is simply equal to 2. And when x is equal to 4, u is equal to 3. So now our bounds change from 1 to 4 to be 2 to 3, and we can begin our substitutions. Ln of root x plus 1 becomes ln of u, and dx is replaced with 2 root x du. Once we get to this step, we see we have a bit of an issue. We still have a root x here. So we have to look back to our original u and see if there's any way we can replace the root x. And it turns out if we rewrite this so that root x is equal to u minus 1, we can make a substitution. So that's what we do here. We replace root x with u minus 1. And then the final step is I just brought the constant that's in the middle of this equation up to the front. So our integral now stands at from 2 to 3 of 2 ln u minus 1 du. And now with this equation, we need to use integration by parts. So we need to select a u and a dv. For clarity, I will use u1 and v1 for this integration by parts section. So u1 I've selected to be 2 times ln u, which means everything else that remains is dv1. In that case, that is u minus 1 times du. In order for us to find du1, we simply take the derivative of this and slap on a du. So the derivative of 2 times ln u is simply 2 over u, and here's our du that we slapped on. In order to find v1, all we do is take the integral of dv1, and so our answer will be u squared over 2 minus u. And now we can put our equation back together. So this is the original equation that was up here, and now we need to use our integration by parts formula on the right-hand side. So what we get is, this is u1 times v1 minus the integral of v1 du1. And now we need to simplify. The left-hand side, there's really nothing to simplify. Make sure you don't forget to put your bounds for both equations. We won't evaluate till a few steps further down. Now let's look at this integral. In order for us to simplify, I have u squared over 2 minus u times 2 over u. So I'm going to bring this in by multiplying each term. So u squared over 2 times 2 over u is simply 2u squared over 2u. And minus u times 2 over u is minus 2u over u. We just simply multiply the numerators together and we multiply the denominators together. And now again, we don't do anything here. There's really no simplification. But here we see that there's a couple of things that simplify out. The 2 and the 2 cancel out, and u squared divided by u is simply u, and 2u over u is simply 2. So these two also cancel out here. And now we can evaluate this integral. This integral evaluates to be u squared over 2 minus 2u, and we need to substitute in our number still from 2 to 3. And now we can finally begin our substitutions. So we always substitute our top number in first. So 2 ln 3 minus 3 squared over 2 minus 3. Subtract, and now we're going to plug in our bottom number, 2 times ln 2, bracket 2 squared over 2 minus 2, close bracket. And I've used square brackets here to indicate this is the solution for the first integral that we're evaluating here. Minus, and again I'm going to use square brackets to show what this evaluates to. This will be 3 squared over 2 minus 2 over 3 minus 2 squared over 2 minus 2 times 2. And be careful and make sure your brackets are lining up properly. I forgot my closing bracket here. And be sure to use brackets between subtraction signs because the subtraction sign applies to every term. Alright, so let's begin simplifying. This simply turns into 9 over 2 minus 3. Can't really do anything here. This here, 2 squared over 2 is 2, and 2 minus 2 is 0. This means this entire term is going to go to 0 because 0 times anything is 0. Minus And we're going to simplify this side. This will become 9 over 2 minus 6 minus, in brackets, 2 minus 4, close brackets. And we continue our simplification, opening up our negative sign, our bracket that's here. So we get 9 over 2 minus 6, and then negative times 2 is negative 2, and negative times negative 4 becomes plus 4. 2 more lines of simplification, and we end up with our final answer of 3 ln 3 minus 1/2. This is the solution to this original equation here, and what we had to do was first do substitution, then we had to do integration by parts, and then evaluate our integral at those bounds from 2 to 3. And that's it for this question. Hey, thanks for watching. Grab the PDF from below, and remember, the best way to study is to join the Grade Savers review sessions.